Every creature has a place in nature, be it a predator in the jungle, an insect in the air, or plankton in the depths of the ocean. Each one is an important part of the food chain and contributes to the ecological diversity on Earth. What can we do to preserve our biodiversity? That's what we'll talk about today. Hello and welcome to Eco India. I'm Sanuda Raghu. Let's head to India's Himalayan region first, where grazing and rearing of sheep has a long tradition. But the change in wool production and consumer preferences has meant that the use of traditional Himalayan wool has declined massively, with a direct impact on the region's ecosystem. Some organizations are now trying to change this. Let's see how.
With whistles and calls, Suresh Kumar keeps his flock together. The shepherd has been tending his sheep in Himachal Pradesh's grasslands for the last 25 years.
As a kid, I used to love goats and sheep. My uncle used to ask me to accompany him and see how they lived in the wilderness. And he taught me how to live there. That's how I got attached to the animals.
Suresh Kumar belongs to the semi-nomadic Gaddi tribe. He earns about 30,000 rupees or less than 400 euros a month from the sale of milk and wool. But in recent years, it's become increasingly hard for his flock to find food, a crisis affecting many sheep herders in the region.
My uncle and I used to have 3,000 sheep. Now we have 700 to 800. The number is plummeting day by day. Our environment has changed a lot. Look, it's not autumn yet, but the leaves are falling. Trees are losing leaves, and this will lead to a grass shortage for sheep in the winter. If the leaves fall early, what will our sheep eat?
Every summer, more than 100,000 shepherds like Suresh migrate to higher altitude pastures in search of grazing land, traditionally staying on until the arrival of winter. But as the climate changes, this practice is becoming more and more difficult, explain experts from the Center for Pastoralism.
Because of this low rainfall, they have faced the crisis of feeding water to their livestock. All the streams and everything is dried up. And they moved 15 days or 20 days earlier, which was not happened before.
In addition to changing weather patterns, urban development has reduced the amount of grazing land, compounding the shepherd's predicament. According to government reports, India lost more than 5.5 million hectares of grasslands between 2005 and 2015. The lack of food for their livestock is becoming a challenge for herders, affecting the health of sheep and in turn their produce.
A lot of the grasslands have been taken over for developmental purposes, industrial purposes. There is enough research to show that grasslands are actually carbon sinks, because they hold much more carbon below than above.
Neshram Kashyap is well known here in the Chichogi village of Himachal Pradesh. He too belongs to a family of semi-nomadic herders and is also a skilled artisan. He weaves local wool into the traditional clothes worn in the region. Himalayan shepherds have traditionally adopted skills like weaving, crocheting, and spinning to boost their income through the sale of wool and woolen garments. But the decline in numbers of local sheep breeds have impacted local wool production. And India began importing finer, long staple wool some 30 years ago. When import tariffs were lifted, it flooded the market.
Nowadays, for the patto that people wear, locals prefer weaving them out of synthetic cashmere and nylon, which are softer. They prefer wearing these fibers as well. The yarns are also cheaper. Cashmere is more colorful too.
उसको ज़्यादा पसंद करते हैं.
As they could hardly sell their wool, more and more shepherds went on to replace their native stock of dual purpose sheep, ones that produce both wool and meat, with foreign, hairy breeds that produce only meat, changing herd composition and affecting the region's ecological balance.
Raising a foreign breed is a bit problematic here. The local breeds of sheep can survive with less grass, but the foreign breeds need more. If there is not enough, they starve.
To help revive local wool, Swati Seth has launched Color Caravan, a social organization that sources indigenous wool directly from herders. They train and hire local artisans like Neshram, thus helping herding communities slowly return to sustainable livelihood practices.
When we started working with Desi Oon, initially there were just a couple of farmers. We were also doing very small quantity. Now, thankfully, we are like connected. We have access to two huge herding communities in two valleys of Himachal. We'll be connected to about 50 to 60 herders. And have like own about 4,000 to 5,000 sheep.
Color Caravan is part of the Center for Pastoralism's Desi Oon initiative. They are cooperating with many grassroots organizations to support shepherds, protect local culture and animal breeds, and protect the environment at the same time.
Our advocacy for the indigenous sheep breed and the wool of that indigenous sheep breed comes essentially from the resilience of the breed. They are far more resilient to the ecologies of their own region, to climatic shifts and changes. They cost less.
This cost factor could persuade other shepherds to take up herding local breeds. The herders are the mainstay of the project.
I'll continue to do this work for as long as I can. Since childhood, I have loved my flock. Though my real family is back at home, this flock is also my family.
And only if they preserve this age-old tradition will they be able to help ensure the survival of the Himalayan grasslands.
From the sheep in the Himalayas to earthworms, which are found almost everywhere in the world. They are integral to our agriculture and thus essential for our survival. But modern farming practices have taken a toll on them. A school in Berlin is making sure its students understand the importance of this often neglected being.
A special lesson is getting underway at this Berlin primary school, and it's one where spades come in handy. This class are learning about an animal most of us rarely see, but which is critical for our survival. Wriggly and slimy, earthworms aren't the type of animals humans typically enjoy getting close to. But these children know it's worth taking a closer look.
At first, I thought they're probably really boring and stupid. They're probably like a snail, really slow. But now I find them really cool.
I think they're interesting, but they move around a lot and definitely look a bit gross.
I find them really funny because, for example, when they're on your hand, some move really quickly and others slowly.
Earthworms are industrious invertebrates. They play a key role in many of the mostly unseen processes that go on in the ground beneath our feet. In places where they're a native species, like Europe, they're vital for soil and plant health.
The earthworms aerate our soil and make our plants stronger.
Without them, birds wouldn't have anything to eat.
Class teacher Paula Risser has handed out a worksheet about the nutrient cycle. It explains how earthworms eat up dead plants and animals and convert them into feces called casts, which are rich in the nutrients that plants need to thrive. Rissa hopes her pupils will learn to appreciate the tiny creatures.
In my opinion, they should understand the bigger picture, that everything is interconnected. And if I behave well here and am mindful and respectful towards all living beings and plants, then of course I also have a much better, more livable environment.
At this research facility near the German city of Halle, scientists are studying the damage done by modern-day intensive farming practices. Over a sprawling area, they're looking at how soil life fares when land is managed in other ways, both in today's climate and the predicted warmer world of the future.
This cropland creates very unfavorable conditions for earthworms because, you know, it's fertilized regularly, which is what earthworms don't like. They have very delicate skin, and if the fertilization lowers the pH value of the soil, it gets more acidic. And also it's a monoculture, right? So there's just one type of plant that they eat. And it creates a very, very static environment.
Ecologist Marie Zunnemann is taking a soil sample to check for life. The ongoing drought in the region has pushed down earthworm numbers across all land use types.
By now, we haven't found very many. Here's one very, very small one that we found for now.
In recent years, the intensively farmed plots have been all but earthworm-free. That's a bad sign because their presence is widely seen as an indicator of soil fertility. In grassland plots like this pasture that's grazed twice a year by sheep, as well as organically farmed plots, earthworm numbers are higher. Martin Schädler is the project's scientific coordinator. He explains how the presence of earthworms also points to the soil's resilience.
The recovery of the vegetation, for instance, also in the grassland plots is pretty good after these dry years, but it's pretty bad in the crop fields.
Schädler often presents research findings to stakeholders. He says farmers have become much more interested in how to make the soil fit for the future. So what are the scientists' tips for doing so?
Reduce management as far as possible. This means a reduction of mechanical disturbances like soil tillage and also chemical disturbances. For instance, fertilization by mineral fertilizers is a disturbance of the natural nutrient cycle in the soil, and of course pesticides, which are a huge problem for soil biota.
So meadows that entail a high diversity, that have many different grasses, many different herbs, different legumes.
Back at the school garden, the children are putting into practice exactly that. Looking after the soil means looking after the earthworms and the rest of the soil organisms that turn seeds into sustenance.
Let's now take a look at mosquitoes. They're considered a nuisance and often brushed off. Yet, in many parts of the world, including India, they transmit deadly diseases. Could genetic modification be a real solution to this problem? And if yes, what impact could such an intervention have on the ecosystem? Let's find out.
They are so small, you can hardly see a difference between the various species. There are more than 3,500 types of mosquitoes, most of which are harmless. Only a few are dangerous for humans, like the Anopheles mosquito. It transmits malaria mostly in tropical and subtropical parts of the world, for example in large parts of Africa and Asia. Today, malaria is responsible for around 80% of mosquito-related deaths, and almost all of those are children under the age of 5, the majority living in Africa. Scientists have studied the Anopheles mosquito for more than a century, looking for ways to control and destroy it. Larvicides, insecticides, they've had varying degrees of success. The insecticide DDT, for example, is very effective. It was used universally until it was determined to be toxic to other species and humans, that is. Now it's banned in many parts of the world. And mosquitoes have quickly become resistant to other insecticides. So, over the last few decades, scientists have turned to a new way of reducing mosquito numbers: genetic modification. A team of scientists from London are genetically modifying Anopheles gambii mosquitoes, the species that transmits malaria in Africa. Only female mosquitoes can bite humans and transmit malaria. Their mouths, known as proboscis, can pierce skin. In addition to quenching their thirst, drinking blood also gives female mosquitoes the proteins they need to make eggs.
We focus on genes that are able to impair a mosquito reproductive. And we were able to manipulate this gene and generate female mosquito that have male traits and do not bite.
To edit the gene, they used CRISPR, a relatively new technology that is used to modify DNA. As a result, even the female offspring of the modified mosquito were born with mouth parts that could not pierce skin, rendering them unable to feed from blood, and it also made them sterile. Now scientists had a genetically modified mosquito, but they wanted to ensure they could spread the modification throughout a wild mosquito population. Normally, when a mosquito with a modified gene mates with a non-modified mosquito, half the offspring would have the modified gene and half would be normal. But scientists have another trick up their sleeves. It's called the gene drive, and it's very controversial and pretty awe-inspiring. A gene drive increases the odds of the modified gene being passed on to offspring. That means that individuals with one copy of the modified gene inherited from their father can now copy the modification onto the unmodified gene inherited from their mother and pass on the gene to up to 100% of their offspring. This means that if the mosquito with the modified gene breeds with one from the wild that is not modified and has 10 offspring, for example, almost all of them would inherit the modified gene. So eventually, and after the modified gene is spread in the population, more or less any female offspring would be born sterile and unable to bite. As part of Target Malaria, Crisanti and his team have already performed tests. They used laboratories created to mimic natural conditions, like realistic temperatures, humidity and lighting to stimulate sunrise and sunset. And it worked. In each generation, most females were born sterile. Unable to breed, the population died off. The genetic modification combined with the gene drive led to the complete collapse of the test population within a year. So that was in test conditions. If released into the wild, these genetically altered mosquitoes have the potential to drive the Anopheles gambiae species to extinction, and that would drastically reduce malaria transmission. Mosquitoes don't typically travel far from where they are born, although that depends on wind and other conditions. Crisanti believes the modification would not necessarily reach all areas where the species is found. But containment of living animals isn't always so easy. Take the rat. As humans began to travel the high seas, rodent species stowed away on ships. They ended up overwhelming island nations. Then there's the cane toad. It was brought to Australia to control the cane beetle, but began breeding uncontrollably and became a pest in its own right. Gene drive opponents argue that, like invasive species, genetically altered mosquitoes would migrate.
It's really a concern that these organisms will spread uncontrollably and possibly crash populations or possibly lead to extinctions of species. They're designed to spread aggressively throughout a species and also to spread geographically across borders.
There are international treaties on biosafety, but they don't consider risks posed by a modified gene drive. The EU and some other nations have flat out rejected any release of gene drive modified creatures within their borders. But let's face it, animals don't care about international agreements, and they don't respect our borders and boundaries. Another question is, how would the potential extinction of the Anopheles gambiae mosquito impact ecosystems? Just like bees and butterflies, many mosquito species are pollinators, transferring pollen from flower to flower. So what would the disappearance of the Anopheles mean for plants? And what about the fish, birds and bats that feed on mosquitoes? Then there's the genetic alteration itself. There is the possibility of it being passed on to other species of mosquito, putting them at risk.
Scientists have a pretty good idea of how these gene drives will work in situ, but it's a very big question. Obviously they can't predict everything that could go wrong and all the implications of it.
Wiping out species that cause death and destruction may sound positive, but once they're gone, what's next? Where do we draw the line?
Using a technology that's, instrumentalizing extinction as a tool, that's a new threshold that human beings have not crossed before.
Shouldn't just reject this because we're like, humans shouldn't be gone. But we also shouldn't just jump straight into the technology, and it has real risks. And so we need to play that careful line of like really thinking through the first use of these things and what that will look like and how it will work out, and take reasonable risks.
As scientists still don't know enough about the potential consequences of unleashing animals with a genetically modified gene drive, it's hard to evaluate the risks.
A small population of sea otters lives in the western Indian state of Goa. They're very important to the region's ecological balance. Yet, they face the threat of extinction because of hunting and pollution. A local organization is working to preserve this species and its habitat.
On a ferry to Chirao, a sleepy island on the Mandovi River in the north of Goa, a secluded spot enveloped in dense mangrove forest, and nestled among it is a surprising resident. The elusive smooth-coated otter, or Lutrogale perspicillata. A rare picture, as these animals are shy.
And I think I've seen otters maybe 12 times. So that gives you an idea of how hard it is to actually spot an otter.
Wild Otters Research, a wildlife research organization based in Chirao, was founded in 2014 in order to study and work towards conserving otters. The medium-sized mammals inhabit most of the waterways and coastal areas of Goa. This year, the ecologists are mapping an estimated 4 to 5 otter family groups in Chirao. Each group is estimated to have 2 to 6 members. In the last years, they have seen more groups, but some of them seem to have moved to other places on the island. In other regions, group sizes are believed to be twice or even 3 times that number. A shy species that's hard to observe in the wild, otters have mostly been studied in captivity. Aiming to bridge this gap, Wild Otters Research is studying, among other things, the animal's reproductive behavior in the mangrove ecosystem's wild and diverse environment.
We have evidence of pups being born in May, which is contradictory to all the historical data. Now, is that because this is a highly productive environment where where there's a fish supply throughout the year and there's no problems with that? Is that the reason they've had pups at that time of the year?
With focus often being on charismatic megafauna, large animal species with symbolic value, Wild Otters wants to raise awareness of the pivotal role smaller animals like the otters play in balancing the ecosystem.
I'll give you an example. On Chirao, there's a number of commercial fish that go into the fishing pools. And alongside that was something called the Madagascar tilapia, which was an introduced species. And this tilapia species was introduced into the waterways here because they kind of predate on mosquito larvae. And then they took over the ecosystem and started actually killing all native fish species. And then otters came along, and even though they're not a native species, otters prefer them and have started eating them.
That helps the original ecosystem to recover. The self-funded Wild Otters Research Organization has already taught otter conservation to around 500 people through internships, workshops, and training programs. The trade in fur and body parts, loss of habitat, water pollution, and human-animal conflict has resulted in this species being classified as vulnerable on the International Union for Conservation of Nature's Red List. Today, on Chirao, the mangroves are protected by law, and part of the island is itself a sanctuary. and there are only a few scientists and tourists. It is little wonder then that Charao has become a safer haven for otters.
Our planet thrives on balance, which is why the smallest organism, the largest animal, and everything in between is important for its good health. Threatened and extinct species lead to an imbalance, forcing the Earth to self-correct. This often comes with disastrous consequences. Think about that, and I'll see you again next week. Goodbye, and thanks for watching.